Hi students, I am going to start a new chapter, Motion in a Straight Line. Let us have a quick recap of the theories. The first one is displacement. What do you mean by displacement? And displacement and distance, what is the difference? Suppose this is the initial point A and this is the final point. A body has traveled from A to B along this path. The distance is the length of the path. Understood? A body travel along this path. The distance of the body is the length of the path. So the distance is simply the path length. Understood? The distance is simply the path length. So this is distance. Then what is displacement? The displacement is the shortest distance between initial and final point. Clear? Draw a line joining initial and final. That one is said to be displacement. Clear? This is displacement. When we talk about displacement, it has a direction. For example, 20 meter towards north direction, 30 meter towards east direction, like that. The displacement has both magnitude and direction. But when we talk about distance or path length, it does not have any direction. Distance 10 meter, 20 meter, like that. We don't specify the direction. Understood? So the displacement, distance, the difference is clear. The next is velocity and speed. What do you mean by velocity? The definition, velocity is equal to displacement divided by time. Displacement divided by time. Meaning that in 1 second, how much displacement? I have already explained the meaning of displacement. In 1 second, how much displacement? The unit is what? Meter per second. And what do you mean by speed? Speed is simply the distance divided by time. Distance divided by time. The unit is again meter per second. Clear? Distance by time. Clear? The distance I have already discussed. The path length. So the velocity and speed is clear. The next is acceleration. Let us have a quick recap of the important terms. What do you mean by acceleration? Acceleration, denoted by the letter A. Acceleration is defined as the change in velocity. Change in velocity divided by time. In 1 second, how much change in velocity? Understood? In 1 second, how much change in velocity? The unit is meter per second square. Clear? So all these are clear to you. Okay. The next is the important formula. Kinematic equations. Kinematic equations of uniformly accelerated motion. Uniformly accelerated motion. Uniformly accelerated means a body is moving with a fixed acceleration. There are plenty of examples. For a freely falling body, the body is moving with a fixed acceleration. There are plenty of examples. So the important formula, let us learn without any proof. Kinematic equations of uniformly accelerated motion. There are 3 formula. One is S equal to, before that, V equal to U plus AT. The first formula is V equal to U plus AT. What is this V? V I have already explained, velocity. V is the final velocity, U is the initial velocity. A body is moving along a straight line. This is the initial position. A body is moving along a straight line. This is the final position. U is the initial velocity. u is the initial velocity and v is the final velocity. Okay, so the displacement covered by the body, let it be s. The length between the initial and final, let it be s. And the time taken for this journey is t. And acceleration is a. Acceleration is equal to a. Clear? So I am talking about motion along a straight line. Initial velocity u, final velocity v, the time taken is t, the displacement is s, acceleration is a. So the first formula is v equal to u plus at, the final velocity. Okay. The second formula is s equal to ut plus half at square. Okay, clear. S is the displacement. Third one is v square equal to u square plus 2as. V square equal to u square plus 2as. Okay, clear.